Our solutions for quiz 6, math 251. First problem, we're given a polynomial, asked to find its critical values. Critical values happen when the first derivative is equal to 0. That is f prime of x equals 0. Or when the first derivative is undefined. Fortunately for us, the first derivative of a polynomial function will always be defined. So we don't have to worry about this one. We just need to know when f prime of x equals 0. F prime of x is easy enough to figure out. Derivative of this polynomial, 3x squared minus 6x minus 9. So we want to know when does that equal 0. Well, we have to factor this thing out, or I guess use the quadratic equation or complete the square. I think factoring is the easiest. Make it a little bit easier to factor if you pull out a 3, which all the terms have in common. So what we need is two numbers that multiply to -3 and add to -2. -3 and +1 will do the trick. So we get that this polynomial factors like this. So x equals 3 or -1 are our critical values. All right, next one. Classify each of these guys as a relative max or a relative min by using the second derivative test. Okay, second derivative test, we need to figure out the second derivative. Second derivative is 3x squared minus, second derivative is the derivative of the derivative. So the derivative of 3x squared minus 6x minus 9, which is equal to 6x minus 6. So what we have to figure out is at our critical points, is the second derivative negative or positive? So f double prime of 3 would equal 6 times 3 minus 6. 18 minus 6 is 12, a positive number. And f double prime of -1, our other critical value, is 6 times -1 minus 6, -12. Also a negative number. So let's see, let's switch colors maybe. So based on this information here, we say that 3 is a relative min because f double prime of 3 is a positive number and -1 is a relative max because f double prime of -1 is a negative number. F double prime of 3 is a positive number, so that means it's concave up at that point, so it kind of has this shape right here. And so if it's flat, we must be talking about this point. We're talking about a relative minimum. I'll get rid of that. Explain how you could use the first derivative test. Okay, so what the first derivative test does is it looks at the first derivative. So let's see, to use the first derivative test, we would examine the first derivative. Derivative spelled different. Barely, maybe. Barely to the left and right. Of our critical points. If the derivative was changing from positive to negative. So if to the left it's positive and to the right it's negative, that means it's going up and then it's coming down. So what we have is a relative max. And similarly, if the derivative was changing from negative to positive, we have a relative min. because in that case, it used to be negative, it used to be going down, and then it stops and starts going back up, so we have a relative minimum. All right, number 2. This is a related rates question. You're given a relationship between x and y. You're told they're both functions of t. That's important. And you want to find the derivative of x with respect to t. In other words, you want to find x prime. It tells us x is 2, y equals 1, and y prime is equal to 60. So, okay, let's take some derivatives. We start out with 2 to the x equals y squared natural log of 2 plus some mess, 3.3, whatever, 3.3, I'll write it, 0.6853, blah, blah, blah. Okay, we go to take the derivative here. Be careful, we're treating both the x's and the y's as functions. So the derivative of 2 to the x is not just 2 to the x natural log of 2, because x is a function, so we have to use the chain rule here. We have to multiply this by the derivative of the inside function, which is x prime. On the right-hand side, we got a constant out here, so its derivative is 0. We can ignore it. Natural log of 2 is also a constant. Careful, that's a common mistake people make. We're going to leave that alone. It's just a number, natural log of 2. And we're going to multiply that times the derivative of y squared. Again, that's not just 2y because y is a function. We have to use the chain rule. We have to multiply by the derivative of the inside function, y prime. And now what maybe you'll notice, I was hoping you'd notice, is you have a natural log of 2 on both sides of the equation. So we get x prime with 2 to the x times x prime equals 2 to the y. 2 times y prime. These natural logs of 2 cancel out. And so therefore x prime is 2y y prime over 2 to the x. See, we know that y is equal to 1, y prime is equal to 60. So 2 times 60 times 1 is 120. And then 2 to the x is 2 squared is 4. We get x prime is 30. An alternative way to do this same problem. I don't know if it's easier or not, but if you don't remember what the derivative of 2 to the x is, there's a way around that. You can say, all right, we got 2 to the x. What was the original problem? Equals y squared natural log of 2 plus 3.306853. So what we can do, I don't remember the derivative of 2 to the x. It's okay, take log base 2 of both sides of this equation. Or you take the natural log of both sides of the equation, whichever you prefer. But if you do log base 2 of both sides of the equation, you'll get x equals log base 2 of y squared times natural log of 2 plus 3.306853. And the advantage to this is now it's easier to take the derivative of the left-hand side. Derivative of x is just x prime because x is a function. Unfortunately, the right-hand side, not that easy, but we can deal with it. It's a chain rule. Outside function is log base 2 of whatever your argument here is. So we're going to say 1 divided by y squared times natural log of 2 plus 3.306853. The derivative of log base 2 of x is 1 over x times the natural log of 2. But then you're not done. You still have to multiply that by the derivative of the inside. The derivative of the inside here, natural log of 2 is a constant. So 2y y prime times natural log of 2. So you get this huge mess right here. Maybe we can simplify it a little bit. See, we got a natural log of 2 and a natural log of 2 that'll cancel out. So we get 2y y prime over y squared natural log of 2 plus 3.306853. And you could try to figure out what that's equal to. It's kind of a pain. Or you can get kind of clever and be like, wait a minute, y squared natural log of 2 plus 3. What I have in the bottom here is exactly what I have right here. Earlier in the problem, I said that that's equal to 2 to the x power. Right? I could go back and substitute, get rid of all this crap on the bottom, and write 2 to the x. I could say that my answer is 2y y prime over 2 to the x, and 2y y prime over 2 to the x is exactly what we got here. So we substitute in, we get 120 over 4 and say that that's equal to 30. So I think the second way is a little bit harder. I kind of like the first way better. But if you didn't remember the derivative of 2 to the x, you might have to do it the second way. So there's a couple ways to do the same problem. That's the end of this quiz.